What's next in your notes? The hours of daylight in Seattle oscillate from a low of 8.5 hours in January to a high of 16 hours in July. You probably never thought about sunlight like this, but dead of winter, at least around the sun, right? And then what happens is it starts growing until you peak at the summer solstice and it starts doing what? Going down. That's straight for you. It is. It's straight. I hate it for you, but even sunlight can be ruined by treading ocean. Let's see here. Let's get a graph because that'll help us out. So the hours of daylight in Seattle oscillate from a low of 8.5 hours in January. We're going to put that at the origin. To a high of 16 hours in July. I'm horrible with months, so we got that. This is January, February, March, April, May, June, July. There's July. Okay. They go all the way to 16 hours. August, September, that was July, right? August, September, October, November, December, back to January, which would be 8.5. And your graph is something like that. Can you choose what that would look like? That's a trig function. Well, it is. Where's the midline going to be? No. The midline is half of the graph. It's going to be halfway between 16 and 8.5, isn't it?
12.25.
Yeah, 12.25. That's 16 plus 8.5 over 2, which is 12.25. Go ahead and put that on my graph there. It's not really there, but put that in there. I need that so I can decide which function I want to use. Do I want to use sine? Do I want to use cosine? Do I want to flip one of the two? Something along those lines. What else do we need? We need a period. You can either do your period using days, but given what they want here, they want you to decide basically what month you're going to plant your garden. So you can do a period using 365 days, or you can do a period of 12 months. 12 months in a year. Okay. So your period's 12 months. We need that. What else do we need to decide? We need to figure out the amplitude of this graph. So, 4.25, 3.75. Your amplitude would be the high value, take away the midline. That is 3.75. All right, let's decide if we want to use sine or cosine, or if we want to do maybe a reciprocal one or two. Not necessarily reciprocal cosine. The negative cosine. Very good, Kiwi. Why did Kiwi suggest the negative cosine?
I don't know, maybe she told us.
Go ahead.
It's because cosine starts up one, so just flip it and then it's down.
Cosine starts high, doesn't it? If you make it negative, how does it start? Low. Anything else is going to require horizontal shifts. Because
Sine would.
Huh?
Sine would.
Sine would require a horizontal shift, because if you want to do sine, you're going to have to start right here, aren't you? So if you don't want to do a horizontal shift, you negate cosine. So we're going to use this form, f of x or whatever it is. I guess f of m because it's the months, but I don't know. Yeah, we'll go with f of m. F of m is negative a cosines of, how's that go? B theta plus midline. Okay. Since we're not doing a horizontal shift, we can just use B theta. K, and it's been 3 or 4 days here, K is your midline. Got it. We know that. We know the amplitude. We don't know B. How do you find B? 2 pi over P. B is twice pi over the period. So twice pi over 12. Pi over 6. I should have made that name, shouldn't I? Since I'm doing months here. Amplitude, we said was 3.75. Cosines of pi over 6 times whatever month number it is, plus the midline, which was 12.25. So if you like gardening, here you go, because I'm sure every home gardener does this, right? Every home gardener does this.
Do you think this is how they do it to put in flowers on that?
You know, I'd have to look that up. I highly doubt it, to be honest with you.
Because they always, or like on some of those like farmer calendars, it's like this is the best day to plant this.
A lot of that's based on historical yields.
How do they know the best day to fish and all that stuff?
I have no idea.
That's the only thing I've ever not had you come and answer on.
Most of the stuff in the Farmer's Almanac is just made up, Cora. There's no actual science behind it.
How it is for you.
They just happen to be fairly decent guessers, but they're only right a little, they're not even right half the time. But I mean, some of it is historically accurate. Your dad's a farmer. He's going to plant corn first week of March?
I don't know.
No, why not?
I don't know.
They're freeze.
Oh, okay.
It's risky to plant corn last week of March. Shouldn't plant corn until around last of the first week or second week of April, otherwise there's frost alert.
You know the only way I remember that is because we plant on Tessa's birthday, my little sister, and we harvest on her birthday.
Some farmers will plant,
That's the only. That's,
not even do, not but maybe 20, 30 miles or south here, you usually get away with planting corn last week of March. But where I live in Palmersville, that's risky. Somebody will do it this year. Somebody's going to plant corn first of March this year because it's warm. If I was planting corn this year, I'd go ahead and do it on a couple of acres, just see what happens. Wouldn't lose much money. Just out of curiosity. Somebody do it. Anyways, what's our goal here? We want to know when there's going to be 14 hours of daylight. So this whole F of M, what's it going to get replaced with? 14. I don't think we're going to see anything show up that's going to be something we know what to do with. Probably going to have to use technology. But it is what it is. All the real interesting stuff does use technology. You subtract 12.25, I think you get what? That's right. You divide by your negative 3.75. I'm too tired to do that. I can tell you it's going to be negative, so as far as I can do it. What's it end up being?
oh my gosh, this was like
Negative 0.46.
Negative 24 with a 6 repeating?
Negative 0.4.
That makes more sense. Let's go ahead and make that cosine of u. I'm going to have to use u minus the seams. Not necessarily u minus, but the goal here is to figure out where cosine is negative 0.46. How do you do that? Arc cosine. So u is going to be the arc cosine. Negative 0.46 forever. Let's see, so using an older calculator here, they should be in radian mode. Check it. Should be in radian mode. Because that's a,
How do you go?
huh? Hit mode. Yeah, it's for juniors. They've never used those calculators at all. Just hit the mode key.
I think, is this one we used in like 8th grade?
We used them to me last year until I got new ones.
Are you serious?
It wasn't until the end of last year that I got new numbers.
Aren't you like the last math teacher who took them?
Because I still had all my old ones. Anyways. But the cosine, negative 0.46. 6666, whatever. There you are in radians. About 2.05 rads. Now we have to do that 2.05 rad.
Probably.
As I said, we got to set equal to pi over 6n, right? We don't need it to be a degree. I mean, this is a pi rad right here, isn't it?
Yeah.
Remember we use the U method here? Pi over 6 months is equal to 2.05 rads.
Oh.
We're not going to end up with a degree or a pi rate or anything, so then we're going to end up with a month. So you multiply by 6, divide by pi. Times 6 divided by pi. 3.93 roughly. Now the way we set this thing up, 0 is January. Wasn't it? So 1 would be February. 2 would be
Sorry, in March.
March. 3 would be April.
What?
What?
0 is January.
Yes.
May. 1 is
January.
That's what I said, 3 is April. We're not going to 4, we're going to 3. There's a 3 there, isn't there?
That's true.
It's the end of April though. 3.93, it's the end of April. It's still April. Just the end of it. Probably last week of April. End of April is when you plant your garden, because every gardener does that. Every gardener obviously does this. Actually, most people just do what their parents do. Their parents probably learned it from trial and error. Here's another one. This is the author's monthly gas unit in therms. You ever hear of a therm? Thermal unit, that's all it is. How much thermal energy is available in a gallon of gas or whatever. But this is its usage in therms. Find a function to model the data. It behaves a lot like what we just saw. It says gas usage. When's he going to use more gas? It's colder. It's cold. You can use the least amount of gas when it's hot. So you can kind of see it.
Is that how gas works?
It's how it works. This is talking about heating his house.
Oh.
This is not talking about like a typical
How
southerner
are
who
you
lives
gonna
in
drive
BFE.
away from-
This is about somebody, I think your author here is actually British. But, so this is his apartment.
Well, I feel like I do.
You're not a city girl. How would you know?
Oh, maybe something happened to the gas, like you just changed it around.
That's a curve, isn't it? Means it can be modeled with trig. There is a huge problem with this one. You're going to have to do a horizontal shift. The reason I say that is because the peak is right there. Midline would be somewhere in here. So you're going to have to do a horizontal shift. Now, if you do the horizontal shift, which function would you be using?
Sorry.
Cosine. Cosine starts out. Okay. And because I had to see the horizontal shift to see this, I have to use f of theta is some amplitude cosines. Oh, how's that go? B times theta minus h plus k. Because there is a horizontal shift. And I would make January 0 and February 1. What I would do. The nice thing about this graph is theta is the same as it was last time. How many months are there up there? 12. 12, then you'd expect that to be your period, wouldn't you? So your period is still 12. You can glance back, but that gives us what we needed. Yeah, V is pi over 6, just like it was on the last example. We
Wait,
shifted,
why is the power 6?
because the period is pi over 12, and V is defined
Oh,
to
it's
be,
2 pi over 2.
there you go. You're shifting to the right one. So -1. We need to figure out the amplitude and the midline, that's about it. I had to look at the textbook to make sure on this one, but that's 154. And that's the bottom piece, that's 20. I wouldn't guess it other than the table either. But anyways, the top one's 154, the bottom is 20. So if you take 154, you add 20, divide by 2, you get your midline. There you go, midline. It's y equals, and again, that's 154 plus the bottom of 20 over 2. That's the middle, about 87. Well, that piece is done. What are we missing? Amplitude. 67. 8, no? Yeah, it is, it is 67. 20, 87, and 67. There's your function. That was all they asked us to do.
So you subtracted the lowest, did you do that by subtracting the lowest point from the midline?
Or vice versa.
That's not how I
You could
did it.
do,
You can do
Yeah, I just
one,
it's a lot
subtracted.
easier.
you can do 154 minus 87, couldn't you?
Oh, that's not what I did.
What'd you do?
154 minus 20 divided by 2. But I mean, it's,
That works.
okay. I was just, you started saying a different way. I was wondering.
It's more than one way to skin a cat, isn't there?
Yeah, I'm gonna
That's a
try to
really
skip the
old
cat
saying.
thing.
It's probably not even said anymore. That's a really old saying. That's that one. It's not that bad, is it? Let me show you the way we used to do this, and the way, if you ever do any of this in the future, what you'll do. Go ahead and grab yourself a TI-84. Go to that last example. You know, we teach a lot of math. Most math teachers, including myself, sometimes wonder why we do it. You can do all this in the calculator. Every bit of it. You remember what you did with data and tables?
No.
X is going to list 1.
Oh, yeah.
Y is going to 2. But if you ever have to do any of this in the future for your job or whatever, where you're actually modeling equations or stuff, and you realize it's a sine function, you'll use technology to do it. I mean, you're not going to sit there and do it by hand. For one, you might be wrong. There we go. See, list are under stat, edit. Everybody have list 1 and list 2? Anybody missing a list? Okay.
Did we skip the last thing?
We're going to go back to it. I jumped to this because the reality is in the real world, you're going to use some sort of technology to do this. You're not going to sit there and crank it out by hand. But we teach you this stuff so that you realize when you actually see the data, you can think, oh, that's a trig function. What are we doing? You know, even those kids that go into engineering, they make engineering kids take a crap load of math, but at the same time, they show them how to use the software they need. Now, you may not know exactly where to go, but maybe your memories are fresh. What's the next thing you get after result? Stat count. Stat count. You've never done this, not this particular function, but everything's always under stat count.
Are we not doing linear regression?
Why would we?
I don't know. That's just what we used to do.
Yeah, but this is trig. I mean,
Oh,
we just showed that this kind of stuff can be modeled using trig, and this one is gonna be modeled using trig.
sign regression?
Yeah, should be somewhere down there,
Right there, cosine regression.
because you don't need it. Sine and cosine are the same function, aren't they? Except cosine has been horizontally shifted. Oh, we had a lesson. I'm just being smart. Iteration is 3. Does everybody say that?
No,
What's yours say?
ours are old as dirt.
I thought I flashed this one on the calculator. Because yours even mentioned iterations. Yours just went straight to the equation. It's interesting that this one's not. I'm just going to leave it alone and see what happens. I've actually not played with this on something with a newer operating system. I'm just going to scroll down to calculate. Is there much of a disagreement? There you go. The amplitude's about 1.5057. You know B, you know C. It's all said and done. You didn't get that on yours? Of course, that she did. But, you know, if you ever do any of this modeling in the real world, that's what you'll do. I guess something I should also do, you know, Cora did mention, why didn't I do linear regression? Well, you can always look at the stuff you plotted. Got to turn stat plots on. Please, when we're done, turn this back off. Hit second stat plot. Where it says plot off, press enter. Choose on. That was second stat plot. I was number 1 I had highlighted. Just turn it on. And you'll hit zoom. Scroll down to the bottom, you'll see 9 for zoom stat. There she is, zoom 9. Can you see the curvature? That's why we do the sine regression. Because it is. Now, again, turn that off because it really screws up graphing. Second stat plot, highlight, turn it off. Because the old calculators, for some reason, cannot draft if stat plots is on. The color edition, it won't bother at all. You just see little points show up randomly. Like, why are those points there? Because you never turn it off. So that's what you do in the real world. Real world, you get to use technology. Let's see, what else is in your notes? That problem is seriously flawed. I meant to bring a spring in today, but your author doesn't have a whole lot of real world experience. We're not actually going to do this problem. Your author thinks that a spring will, if you pull it out 6 inches, it'll recoil back 6 inches. I've never seen a spring do that. I've got a garage door spring sitting around because one of them broke, so I got 2 of them instrumented. Have you ever seen a garage door spring break? There's a reason you wrap a steel cable to it. It is impressive how much tension is under there. I don't think even in school they actually pull it apart, but they don't compress. They don't compress. So this problem I've been doing because the author has no idea how springs work. It's just a horrible example to use. And he's probably some city dweller who lives in his apartment. This one we're going to do. This one sucks. This is a push rod design. You're into, maybe one day you want to design an engine. There's a map behind that. It's push rod. Look at the description. It says a rigid rod with a length of 10 centimeters attached to a circle of radius 4 centimeters. That'd be your crankshaft in the car or whatever. And as the circle turns, it pushes this rod back and forth. Because as it goes, circle gets down to here, the rod would be somewhere over here, wouldn't it? And once the circle gets back to here, the rod would be closer. So that's your basics of the internal combustion engine, push rod design. So a rigid rod with a length of 10 centimeters attached to a circle of radius 4 centimeters at point A, shown here. The point B is able to freely move along the horizontal axis, driving a piston. If the wheel rotates counterclockwise at 5 revolutions per second, find the location of point B as a function of time. When will the point B be 12 centimeters from the center circle? That's intimidating, no problem, isn't it? A lot of stuff going on there. All right, let's see if we can find coordinates for point A, which means you got to use that memorization. X is, Y is. X is R cosine theta. How about Y? R sine theta. What's the radius of the circle? 4. There is a point that's known. It happens to be at 4 cosine theta and 4 sine theta. It's known. Well, what else we want to know? The wheel rotates counterclockwise at 5 revolutions per second. That's pretty important information. You know, it's period. You rotate 5 revolutions per second. How long does it take to do 1 revolution or 1/2 pi? Takes a fifth of a second. 1 full revolution. It's 5 revolutions per second. Takes a fifth of a second to revolve once. 1 full revolution is 1/5 of a second. That's your period. Then when we graph sine and cosine, what were we doing? We were unraveling the circle. Period is 1/5. Okay. Let's see here. How's this thing rotating? Counterclockwise? Well, I'm glad it's rotating counterclockwise. That's how normal rotate, isn't it? Think about when you were doing your unit circle. That's how we normally rotate. So I'm actually okay with that. Now, what do we want to do here? All right, so let's worry about some other stuff first. I see the potential for a triangle. I haven't done this problem, so this could be interesting. I just assumed I could. Do I need to modify theta any? I don't think I do. No, I don't. Okay, that little leg I drew in. What's her length? 4 sine theta. That's 10. About this unknown piece right here. It goes from here to here. What am I going to have to use to find it? I'm going to use there. Some unknown piece here. A squared plus 4 sines of theta squared is 10 squared. I didn't say this would look pretty. I never said it would. So a squared is going to be, what, 100 minus 16 sine squared of theta? Anything you can really do with that? Nah, not really. You could pull a 4 out and simplify the radical, but there's no need to. A is root of 100 minus 16 sine squared theta. You could say it was 2 root 25 minus 4 sine squared theta, but there's no need to talk about that. There's your missing length right there. This piece from here to here is going to be 100 minus 16 sine squared theta. Does anybody know what this little length is? That's right, Zach. That little length is 4 cosine theta. Now, why did I do all that? Because the goal here is to figure out when the point is going to be 12 centimeters from the center of the circle. That's the goal. So 4 cosine theta plus 100 minus 16 sine squares of theta must be equal to what? 12. God, that got ugly real quick, didn't it? That really did. Oh, and I forgot my square root symbol. Forgive me. That's supposed to be a root of 100. I don't even know that we need to worry too much about the revolutions per second. Maybe we do because we need time, don't we? So that might actually come back into play. I'm going to need more white space. Well, is supposed to equal 4 cosine theta plus the square root of 100 minus 16 sine squared theta. So back in Algebra 2, you learned the technique to do this. If you had 2 equals 5x plus root of, I don't know, 7x, what would you try to isolate? We'll do the easy equation here first. Try to isolate the square root. You subtract the 5x. And how do you counteract square rooting? Squaring. That was the technique you learned last year. Isolate the radical. So we have this fugly looking radical that's got root of 100 minus 16 sine squared that has to be isolated. So what are we going to take away from 12? There we go. Well, take away 4 cosines of theta would now equal the root of 100 minus 16 sine squared of theta. Square both sides. How are you going to handle the left-hand side? Boil it, write it twice. Didn't say it'd be pretty. Thankfully, the right-hand side's easy. Square root. That's easy. I'll let you guys do the hard part. It's not even that bad. What do you get? I agree with that. 4 times 12 is 48. 2 of them, that'd be 96. 144 minus 96 cosines of theta. Negative 4 times negative 4 is positive 16. Cosine times cosine squared theta. And it's still got a whole lot going on, doesn't it? What you know about, well, I tell you what, let's move this over here real quick. I'm going to leave some stuff floating around here, but what I'm interested in is the fact that I had a cosine squared and a sine squared. Move that negative over, it becomes positive. So what do you know about a sine squared plus a cosine squared? It's 1. So what's 16 sine squared plus 16 cosine squared? 16. See, now it's not near as bad because the square has disappeared. That becomes a 16. And what do you want isolated? Yeah, isolate cosine. Move that negative 96 right and make it positive. We'll divide it out in a minute. What would the left-hand side have? It'd have 60, wouldn't it? 144 minus 100 is 44, add 16 sides. 60. Divide by 96. You get 10 over 16. So 5 over 8. Yeah, that's right. 60 over 96 is what divisible by 16. That's 5/8. Now, all that whole entire page was just to get that. How do you find cosine? Oh, you didn't have to worry about the U method here. You just do the arc cosine 5/8, right? Turn on. There we go. Cosine 5/8. 0.8956 rads. That's sadly not your answer. Your answer was when, wasn't it? When. How many seconds does it take? We don't actually have to write an equation modeling the circle or modeling anything. It takes 1/5 of a second to rotate. What, 2 pi? Yep. So I don't think we have to write an equation or anything. I really don't. It takes 1/5 of a second. The goal here is if it takes 1/5 of a second to rotate 2 pi, how long does it take to rotate part of it? I don't know. I mean, we can do it with the formulas if we really want to, but we don't have to. What you could do is you could find the proportion that 0.8956 is to 2 pi. You could use proportional reasoning. You could say 1/5 of a second is to the time as 2 pi is to the amount of rotation that you need. It's called proportional reasoning. It should be the same. Did I ever teach you proportional reasoning? And Kyle was suggesting 1/5 is to 2 pi, which is fine. 1/5 would be to 2 pi, as time would be to 0.8956. It's the same proportion. You should do a lot of proportional reasoning in geometry, but you guys may not have been taught it. And I haven't taught geometry since 2016. When I taught geometry, we did lots and lots of proportional reasoning. I do not like this calculator. There we go. So if I multiply 0.8956 by 1/5, I get that. I would have 2 pi t equal to that decimal. So I would divide it by what? 2 pi. Using these older calculators, you gotta wrap 2 pi in a set of parentheses. Otherwise, you get the wrong answer. That's how many seconds it takes. Not long. 0.0285 seconds. Now, if you go back to the context of the problem, you think could potentially have 2 answers. Is everything slow today? There'd be an answer up here. Where else would there be an answer? There'd be an answer down there. Last I checked, it would be. Just take away that from 1/5. You'll have it. Symmetry. Take away what you got away from the fifth, you'll have the other answer. Symmetry.
What's
up, Brody?
I did it a completely different way, and I worked with nice numbers the entire time.
Well, good for you. What'd you do?
I got 1/30th of a second and 1/60th of a second.
What'd you do?
Graphed it. All
Funny,
for
he's
12.
like, oh, nice numbers, one, that sounds awful.
1 minutes, 12 centimeters. You just graph it, solve it 12.
Yeah, we could have done that too. Let's see your slide hand.
Like, do you have new calculators or something?
No, I'm missing 4, so you don't get to use my new calculators. With $1,000 walked out of my room.
How much did you have in your pins?
Those ones I have over 200. And if you guys can't respect nice things, you don't get to have nice things.